In this video, we present FlexCase, a flexible interactive flip cover that not only extends the input and output capabilities of mobile phones, but enables novel physical interactions, all without affecting their current form factor. We utilize flexible thin film technologies, such as a flexible e-paper display and a custom-made combined touch, grip, and bend sensor. Our goal is to bring paper-like interactions to existing smartphones. Therefore, we combine a highly flexible printed input sensor and an off-the-shelf flexible e-paper display. We combine these input and output devices together and developed a smart flip cover for mobile phones that is flexible in both senses of the word. In book mode, the flip cover virtually extends the screen space of the phone and affords paper-like interactions. In laptop mode, the phone is used sideways, allowing the secondary screen to transform into an input device with a dynamically changeable layout. In back of the device mode, the cover turns into a touch and bend sensor at the back of the device that adds additional rich interaction while the main LCD is used. Our input sensor is based on a piezoelectric material that is arranged on a 5x3 matrix. Our system continuously reconstructs the shape of the cover, senses dynamic touch gestures, such as swipes, and detects the exact amount of pressure that is exerted on the sensor. The sensor is able to distinguish between touch at the front as well as the back of the device, and is able to track touch motions and distinguish multiple touch points. We developed a novel machine learning approach that classifies these touch points on both sides of the surface to detect the way the surface is gripped by the user. This allows the user to bend specific regions of our sensor in many different ways that our system can distinguish. We explored various interaction techniques in a number of example applications that FlexCase enables. Here, we demonstrate the use of the cover as an extended visual clipboard. The user composes an email, bends the cover to switch to a restaurant recommender app, and then copies content by tapping both on the content and a free slot in the clipboard. Finally, the user pastes the copied items to the email by simple tapping. In this document viewer, the user quickly flips through multiple pages by bending an edge and turns a single page by bending a corner. Associated high-fidelity graphics and videos are shown on the LCD. Another grip gesture is used to navigate through a video clip. In the map application, the user can transfer a route to the secondary display by closing the cover and performing a rubbing gesture, like with traditional blueprint paper. Moreover, we demonstrate how multiple degrees of freedom inputs can be mapped to 3D navigation and maps by incorporating different grips for zoom, rotate, and tilt parameters. In this camera application, all controls are located on the secondary display, which leaves the digital viewfinder to be free of clutter. Linear camera parameters, such as zoom, can be continuously manipulated by bending a specific corner of the flexible display. The corners can also be used for changing more than one parameter, such as aperture and exposure, by distinguishing between different grip gestures. Certain application scenarios, such as purchasing an item online, requires the input of user credentials while in the presence of potential shoulder surfers. In laptop mode, FlexCase can be turned into a pressure-sensitive keypad. The entered pin is only accepted when the digits are entered with the associated amount of pressure. FlexCase can also be used to control a background task, such as music, by using swipe gestures and corner bend gestures to adjust the volume, all without leaving the foreground app. Finally, gestures at the front and back of the device can be combined. Here, the user pulls back the browser interface to get an overview and selects a website through touch. We demonstrated FlexCase, a novel interactive cover for mobile phones that seamlessly extends the input and output capabilities of existing devices.